taking new notes, or someone at your table should have something from before if you don't. Okay, Israel.
Here.
Felix. Eli.
Here.
Edith.
Here.
Dahlia.
Here.
Stephanie.
Here.
Diego.
Here.
Jamie Lynn.
Here.
Sandy.
Here.
Brandon.
Here.
Brian.
Here.
Juan Carlos.
Here.
Martin.
Here.
N. Kennedy.
Here.
Giselle.
Here.
Caesar. Gustavo. Lirio. Tyler.
Here.
Melanie. Lazaro.
Here.
Jonathan. Messiah.
Here.
Joanna. Kevin.
Here.
Ehong.
Present.
Christina. Johnny.
Here.
Luis. D'Anthea. Ryan. Nice. Good. Good. That's okay. But see if they can kind of help you out with the university right now. You didn't watch the videos of the week?
I did. I assumed I did. I watched the other video right now.
And then you go from degrees to radians. You just want to just pi over 180, and then you simplify it. So here you're going to leave the pi, and then just think 30 and 180 divided by 10, and get 3 pi over 18. Go pi, and then I'll divide by 30 and 180 divided by 10, and get 3 pi over 18. Needing anything else to go to? There's a 1, 3, and then you have pi over 6. So 30 degrees is equal to pi over 6. When you're going the other way, you're going to put in 180 with pi. And the pi is looking okay, looks good as I walk around, so let's get started. Where's my... Welcome back. How was break? Break is good? Good. Need 2 more breaks? Will that be 2 days? 2 more weeks? Happy? I am happy to do 2 weeks in December. No, you got, I think it's 4 weeks.
What is that?
You've got 3 school weeks, and then you got like a half week that's like common assessments and like festival and all that. Because we've got this week, Friday you got a quiz. Next week, more lessons. Then Friday you got a quiz. Then that next Tuesday, you have a unit exam. And then we review for 3 days. Then you have your pre-cal common assessment. So that's on the 4th week. I'm sorry to break it to you. But we're still really close. And it's your birthday?
No, Daniel.
Good. Okay. So a few things to recap really quickly.
I'm gonna break it.
Oh gosh. Eyes up here. Eyes up here, eyes up here. We got a lot to get through today, so voice is off. Okay. One thing that we did before break was converting just between degrees and radians. We talked about what a radian is and we converted, so we're going to go over that in a second. We also, just to jog your memory, talked about SOHCAHTOA a lot, sine, cosine, tangent, and then with those, the reciprocal functions, sine, the opposite is cosecant, and you flip it to the reciprocal. Cosine, you've got secant, tangent, you've got cotangent, right? We also talked about just things that like we need to be reviewing, because remember your problem set, you didn't have to turn into me, so things you should still be practicing up on for your quiz on Friday. We also talked about inverse trig functions, which is different than the reciprocal. So for sine, the reciprocal is cosecant, but the inverse of sine doesn't flip it this way from opposite over hypotenuse to hypotenuse over opposite. The inverse flips like your input and your output. So instead of the angle being inside and the sides being on the outside, remember the inverse flipped and now the sides are on the inside and we're solving for our angle. So we use these. Key idea was when we wanted to solve for theta, our angle, you can use the inverse sine, cosine, tangent button on your calculator, okay? If you're like, ooh, that doesn't ring a bell at all, then make sure you maybe go back to some of those problems we did, or those problem set problems, even though they're not due, and you can practice them, okay? Last but not least, at the end of the week, before we went away for break, we talked about co-terminal angles, which remember were angles that share the same initial and terminal side, so they look the same, except they have different measures, because we said if I want to be right here, I could either add a full circle 360 or I could take away 360 and I'm going to be in the same spot, right? So we found a lot of co-terminal angles. Today, we're going to be using some more co-terminal angles, and we're going to be finding something new called the reference angle. So that's where we're headed next. And tomorrow, you get to learn about the unit circle for the first time, which is very exciting. Okay, so let's convert and make sure we remember how to do that. 4 degrees to radians. Raise your hand if you can tell me just the conversion for those people out there that weren't so sure. What is the conversion from degrees to radians? Dahlia? We're going to multiply times pi over 180, and then you just simplify. So if you simplify 30 over 180, you can divide by 10 and then by 3 or by 30. You're going to end up with pi over 6 radians. Okay, now the other way. When you have radians, you want to go to degrees. Raise your hand if you can tell me that conversion, Sandy.
180 over pi.
You flip it, and we're going to do 180 over pi. So the pi's will cancel. We should not have any pi in our answer when we have degrees. We multiply 180 times 2, then divide by 3. You should get 120 degrees. Okay? For the next two, I'm not going to show the work. I'm just going to show you your answer. You can check them. Negative pi over 4 radians. Negative 210 degrees. Okay? Okay, so that is converting. If you need to convert today, that's what you're going to do. We're going to recap a few of the other things as well as we go. Your new problem set is due on Monday the 4th, next Monday. So please reach out if you have questions as you begin working on that. After today's lesson, you should be able to do all of page 1. Yay! All of page 1, the front side. Okay. Today we're going to talk about trig functions at any angle. Woo! So we're going to learn about this thing called the reference angle, so that whenever I give you like sine or cosine, you can find any of the other ones by drawing a triangle, which we've already done, except now we're going to be able to do it in any quadrant. So if I say like 300 degrees, you guys couldn't draw that right now in a triangle, because 300 degrees is already more than 180, right? But we are going to find a reference angle to help us, and then we're going to be able to find sine, cosine, tangent, all sorts of good things. Okay, so join me right here below the do first where it says explore. Let's explore how we can sketch angles that are greater than 90 degrees. I would say this first quadrant right here between 0 and 90, we're already pretty good at sketching an angle. If I say 45 degrees, y'all know that's like half of 90. So you know it'd roughly be not straight up, but just like this. But bigger than 90 can be a little bit more challenging. I think a lot of y'all would maybe be pretty good all the way to 180, but then maybe past that, not really sure unless you have a protractor or something like that, okay? So we're going to look at this kind of protractor looking thing right here, where it goes in a full circle, and it gives you a lot of the degrees that you guys eventually are going to memorize on the unit circle. But let's say we're talking about the angle 300 degrees, which would go past 90, past 180, past 270, and then something like this would be a full 300. So notice they drew it right here, about right here in that fourth quadrant. Now because that is a really big obtuse angle, you have to like open it up and go all the way around. The reference angle is the acute angle, because we like acute angles. They're like small and we can put them in triangles and they're cute. Yeah. So the acute angle, sorry, the reference angle is the acute angle between our terminal side that we have and the x-axis. So getting back to the x-axis, this right here, that on my PowerPoint is red, marks theta, that is what we would call the reference angle. Because like even visually it's kind of easier for us to deal with that than like the full 300, right? Okay, so that's the reference angle. So if this goes around 300 degrees, can anyone tell me what the reference angle with this red theta is equal to in this case, Messiah? Yeah. We're going to just say like how many do I have left if I were to keep going this way. So 60 degrees left. 60 degrees is going to be our reference angle. If we were to, it's like how many to keep going to our x-axis. Okay? So 60 degrees would be your reference angle. That angle is going to be really helpful later for when I want sine, cosine, and tangent, because I cannot draw a triangle with 300 degrees, but I can draw a little right triangle right here and use 60 degrees and find the opposite and the hypotenuse and all that stuff and find sine, cosine, and tangent of that angle. And because it's on the same terminal side, we're going to be talking about the same spot. Okay? Cool. So that would be 60 degrees. Let's do two more quick examples, one positive and one negative that maybe show up in a different quadrant. Depending on what quadrant you're in, you might have to think about this a little differently. Okay, so 240. Really quickly, turn and talk to your neighbors like 30 seconds. Which quadrant would 240 degrees be in? And then I'm going to pick it someone at random. So everyone talk to each other, go. 20 seconds. I'll pick someone at random, so if you're not sure what quadrant it's in, figure out which quadrant 240 would be in and why. Alright, Kennedy, coming over to you. You've been chosen by the sticks of fate. Which quadrant would 240 be in?
The lower left.
Cool. And if you do numbers, this is quadrant 1, 2, 3, 4. It'd be the third. Cool. But that's a great way to describe it too. The lower left, also known as quadrant 3. You can draw it there. And so we could have our initial side. It would open up, and then it's going to be somewhere in between here. You can actually look and see it right there. But normally we wouldn't have that to look at, right? We would just be able to reason through that it's past 180. And if you add another 90, you'd know that that's too far, 270 down here. Okay, so we know it's somewhere like that. We are looking for the reference angle, which one more time I'll repeat, is a acute angle between my terminal side and the x-axis. So this time, if I look at the angle right here to get to 360, is that acute? It's cool and all, but it doesn't help me that much because it's obtuse. So I am actually in quadrant 3 going to be looking at this angle, how many degrees between my terminal side and 180? Okay? Because see, the x-axis is closer on this side than on the other side. Okay, so let's think if this is 180 degrees and this is 240 degrees, how many degrees between those two angles? Lazaro? 60 degrees. And if you want to actually like subtract and check, 240 minus 180 is 60 degrees. It actually is the same reference angle for two different angles. So notice we're going to end up with the same reference angle even in different quadrants because it could be close to this one or it could be close to the other one. Okay? Alright, last example. Let's talk about what to do if I have a negative angle, and this is going to be a good kind of recap of what we did before break. Negative 150, you could think about counting 150 backwards, but that could be challenging, but you're welcome to try that. So if you like positive numbers, I kind of like positive numbers. Remember we said the week before break, I think on Thursday when we learned coterminal angles, we said any angle can be rewritten in a lot of other ways, and some of them are probably more friendly than others. Any angle, if I add 360 or subtract 360, I'm in the same location, right? So what can I do to negative 150 before I start to make it a little friendlier to the eye? Giselle.
You can subtract, divide the 360
Okay, so subtract 360.
by that 180.
Oh, gotcha. So actually,
Or you can,
because this is what you're saying, like that. But we would need to account for the fact that it's going to be a positive number.
you want, okay.
Wait, yeah. Like you can't just change 150 to a positive, right? But you're doing the math correctly. Like
Okay.
negative 150 plus 360, that's what you would do, is you'd subtract them to see. And what do you get? 210?
30T.
Yeah. 210? Cool. Okay, so 210. Now let's pretend like that. We're back to that last problem where now we're ready to draw it. 210 would be, Edith, in which quadrant? The third one as well. So we're going to be dealing with one very similar to what we did before. So it's going to be somewhere like this. And so your reference angle, again, is going to be the acute angle between this side and 180 or 360. We're going to go back to the 180. This is going to be our reference angle right here. The green shaded. And so how many degrees from 180 to 210?
30.
Yes. 30. 30 degrees is going to be our reference angle, that green little sliver right there. Okay? Again, the reason we're doing this is because the second part of class, we're then going to be using that reference angle to draw a right triangle and find sine, cosine, tangent, all of the fun things. Okay? All right. Brian, question?
So, can you also subtract like the 180 and the 150 or something?
Yes, you got to be kind of careful depending on the signs and things like that. So there are some patterns, which right now we're actually going to talk about some patterns that you can use to kind of help you with that. So you could have done, yeah, that should work. So if you want to stay in like negative land and not change it to a coterminal angle, it is possible. But that's one option is to just change it to positive and deal with it. Okay, so let's generalize though. Kind of go with a rule. You don't have to use the rule. You can reason through it every time and just draw it. But really quickly, let's kind of talk about the patterns you notice. For angles in quadrant 1, what are you doing? Angles in quadrant 2, what are you doing? 3 and then 4. Because notice for 3 and 4, we either subtracted from 360 or 180, things are different, okay? So let's talk quadrant 1. I'm in quadrant 1. I'm an angle in quadrant 1, so draw whichever angle you would like from quadrant 1. I'm going to draw mine like that. Yay, it's so pretty. There's theta. Okay. Yours could be smaller or bigger, but it has to be in quadrant 1. If I want to find the reference angle for that theta right there, is theta an obtuse angle? No. So it's actually already acute. How do I get back to the x-axis? I would just go that same place. So in quadrant 1, your reference angle, you actually don't have to count anything or calculate. If it's 30 degrees, your reference angle is 30 degrees. I can already draw a right triangle using theta. I don't need another angle to help me. Okay? So quadrant 1 spatial, theta is your reference angle. Okay? Alright. Quadrant 2. We didn't do any in quadrant 2 either, so let's see what happens. If I'm in quadrant 2, I'm starting here, and I'm going to pass up 90, and then you can stop anywhere you want in quadrant 2. So let's say I'm somewhere over here. There's my theta, my angle. Jonathan, is it closer to go to 180 or back to 0 or back to 360? 180, right? Like my reference angle is going to be the acute angle right here, right? Between 180 and my angle right there. So in this case, my angle is smaller than 180, but it's still closer to get to 180 than to go back this way. So my reference angle is going to be to take 180 minus whatever this theta is will give me what's left between 180 and that angle. So pretend it's 100. Picture it. And this is 180. You do 180 minus 100, that's 80 degrees that's left right there, right? Okay. Quadrant 2, we done. Moving on. Quadrant 3, we did 2 of them in quadrant 3. So let's see what we did in quadrant 3. If I start here and I go past 90, I go past 180, and then I finish somewhere over here. If this is my theta, all the way around right there, we said that our reference angle is not this little angle right here, right? That's with the y-axis, and it's not this big obtuse angle to get back to 360. We said our reference angle is this acute angle between our terminal side and the x-axis right there at 180 degrees, right? So if we wanted to write a formula to calculate it, raise your hand if you can tell me how to generalize using these examples. What did we do in quadrant 3, Eham?
270 minus beta.
A little louder.
270 minus beta.
If you do 270 minus theta, you're going to get this right here, which works if it happens to be right in the middle and this is split. But like what for 210, for example? Did we do 210?
No.
We did 210, right? Yeah. And we got 30 degrees, right? But if you do 270 minus 210, what do you get? 270 minus 210? 60. That's this part right here, right? That you solve for when you subtract those two. We want the angle, the acute angle formed at the terminal side and the x-axis. So we want this one. So you want to adjust it?
Beta minus 180.
Good. Theta, but minus 180, because this time theta is bigger than 180. So theta minus 180. We're not going to deal with 270. We're going to deal with the 180. The only time you'll get the same answer is if it happened to be right in the middle. But we got to be careful if it's one like that. Okay, and last but not least, quadrant 4. We also did one like this. If I go all the way around the circle somewhere in quadrant 4, then I'm actually not going to talk about 180. I'm going to talk about how do I get to 360, because I could talk about this acute angle right here on this side. That's an acute angle between the x-axis and my terminal side. So that's a reference angle. So we are going to do for that one, running out of marker, 360, because that's bigger than theta. I think we used 300 before, right? And we would subtract theta, or like subtract 300 to figure out our reference angle. Okay? So if you want to reference these and use them to find your reference angle, then you can. But if you'd rather just draw it and kind of like reason it out and figure it out, you can do that. Okay? Alright, so there's 6 problems that you see right below. 3 of them are in radians. So you can either deal with them in radians, or if you want, like to do first, to just change them to degrees, then you can go ahead and do that and then follow the same steps. But I want you to find the reference angle and sketch each of these angles, okay? I'm going to set 5 minutes on my clock for y'all to try this out. On your mark, get set, go. 5 minutes. Try it out with your neighbors. So do you want to do it in radians, or you want to change it to degrees? Okay, so start by like your first 25 minutes, 180 over 5.
180 minus 120.
Good. So then where's your reference angle? Wait, a little part. Good. So this is 120, this is 180.
So 180 minus 120. Would that be 60? 180 minus 20.
Good. And make sure you can actually like do the one division. 3 goes into 36, or 3 goes into 3 once,
Yeah, so
and 3 goes 6 twice.
No.
So this is just like the do first changing it, right? Now, for these problems, you're at like this point where now you have an angle. So now you have to draw it and find your reference angle. So where would 120 be? Second quadrant. So sketch a little angle in the second quadrant.
Yeah, positive. Should I test the positive right now?
Cool. Okay, now where shade, like we shaded here, label theta, where would your reference angle be? Nice. So think about it, if this is 120 and this is 180, see 20 degrees. That would be, yeah. That's your reference angle. Cool. Wonderful. Yep. And then this one's way too big. So kind of like we did here with the negative. From the beginning, we changed that to 10 by adding 36. So we talked about if I have an angle, if I add 36 degrees, if you can always simplify.
It's gonna be on the bottom.
So subtract 360 and make it easier to look at.
No wonder why. Right? And then times it on. And then just do it like college. Yeah, until 80s.
Well, now that you got negative 120, one, if the negative's confusing you, you can still figure it out with negative, but if it's confusing you like this one, add 360 first to make it positive. Wait, for y'all, that first one, I jumped in, I think a little too early. When you got the 120, just be careful because it was a negative. So I think that actually it's still randomly the same answer, and that's why I didn't catch it. So negative 120, if you don't know how to sketch that,
30 will be.
we have to then think of how can I rewrite it as a positive, like we did with this
We
150.
top left, so it's 42.
Add 360 and see what you get. The picture is going to look slightly different, so that's why I wanted to come back so we can resketch it, but you actually are going to get 60 degrees, which does not mean that like, oh, our way works. It just means we just got lucky because there's a lot of angles that have a right.
180 times 2. What is it?
No problem.
111, 270. So it'll be 180 minus 270.
Good.
No, that's
How y'all doing?
If it's in the middle, it's like, for example, this one's in the middle, 270, it'll be a quadrant.
Yeah, you could actually use either of those, right? You'll get the same answer whether you use 360 or 180.
Oh, okay.
Because notice, can you picture how many degrees it would be? Oh, how many degrees away is it from the x-axis?
What?
You are right here.
Yeah.
How many degrees are you away from the x-axis? What angle is this? 90. And even if you use the other side, you go back here,
Oh, okay.
doesn't matter.
Okay.
Are you doing okay converting?
the top one's yours.
How you doing?
Yeah, you don't have to. Yeah, you can. You can memorize.
Quarter one, they're gonna just leave it.
Lovely. Very good.
Right? Maybe
So
quarter
these,
one, just
you
leave
should
it.
go back to the reverse and convert it to degrees. Okay, that was your 5 minutes, so we're gonna check what you got, even if you're not completely done. So we can go on to triangles for our last like 20 minutes. Okay. I'm just gonna run through the answers. I'm not gonna draw the sketches, and so there is a possibility that you get the same right answer, but you did it like the wrong way, because remember we saw that multiple angles could have a reference angle of 30 or 60, but this should be enough for you to check, and if you have a question on one, you can call me over. For this first one, in radians, it's pi over 3, but I know a lot of people might have gotten 60 degrees from doing it in degrees. Just be careful, because if they needed your final answer to be in radians like you started with, if you found that 60, you might need to convert it back at the end, okay? But I'll take any of those for right now. For this one, pi over 4 or 45 degrees. For this one, pi over 2 or 90 degrees. For this one, I assume everyone did degrees, and that would be 60 degrees again, 45 degrees again, 90 degrees again. Okay? Got some repeat answers there. Alright, this next problem is a really good example of how a question like this could show up on like a test or a common assessment. And I think this is a lower level problem, but becomes really difficult if you just don't remember like what a reference angle is, or you don't remember your conversion like we did in the do first. So take a look with me really quick. We're going to answer it as a group just to show you an example of what you could see in the future on your upcoming like quiz on Friday and things like that. And then we'll move on to triangles. So it says express the angle 5 pi over 9 in degrees. So first thing we need to do is do what? Convert it. Multiply times your conversion, find it in degrees. Then, second thing is they want you to determine the reference angle, just like we did. Okay? So convert, then find the reference angle. Boom, you got it. So let's do it really quick together. Martin, what are we going to multiply by to convert it to degrees? 180 over pi. Lovely. Your pi's cancel. I'll do some of the math for you. You get 900 on top, 9 on the bottom. 900 divided by 9 gives you how many degrees? 100 degrees. So, from the get-go, Leo, what two answer choices can you eliminate now that we have the angle in degrees? A and C, goodbye. It's not 200 degrees, it is 100 degrees when we convert from radians to degrees. All right, now we're down 50-50. You're like, I don't remember what a reference angle is. At least you got 50-50 chance, okay? But you're like, never mind, I do remember what a reference angle is because I was listening. The reference angle is the acute angle formed between the terminal side of the angle and the x-axis. So, if 100 degrees is just past 90, here's our reference angle. How many degrees between 100 and 180? And D is your answer. Not bad, right? Okay? Everyone will get that question correct. It makes my heart happy when I'm grading.
Are you sure?
Alright. Let's talk about triangles. Woo! Did y'all miss triangles over the break? No?
I missed a lot.
I missed them.
I need my catfish triangles.
I missed my triangles so much, but I made a bunch of posters sitting around. Do y'all like my new posters?
Yeah, they're very jolly.
I got them. Okay, eyes up here, Brian, for this little picture. Let's talk about what's going on here. Okay, if I give you an angle, any angle I ever want, now we know how to find the reference angle, so we know how to refer to our angle in a similar fashion. Did that just happen?
Yes.
Don't move the table. There we go. Oh,
Well,
but it's stuck.
that's fine. You won't.
You can do it. Whatever, I like blue anyways. Okay, so we've got our angle. Let's say our angle is formed with this initial side right here and this terminal side. They have theta drawn right there, right? We know our reference angle is going to be this piece right here, right? Which means, because that is an acute angle, I can basically drop a dotted line straight to my x-axis and form a little 90-degree angle, and I can draw a right triangle. Okay, notice I did not draw a right triangle. I mean, they drew a dotted line right here, but I'm not going to use the right triangle with the y-axis. I'm talking about back to the x-axis, so I can use this reference angle. And reference angles are always with the x-axis we talked about. Okay, so if that is true, wherever this triangle started is some point x, y, right? It could be like -3, -5, right? Like over 3 and down 5. If that is a point, then that means this side of my triangle is whatever x is, right? It's how much we went over. And this side of my triangle is how much you went down, so this side is what we're going to call y. And then in general, for right now, I'm going to call the hypotenuse r. And that's because later tomorrow when we get to the unit circle, it's actually going to be the radius of our circle. That's going to be like this. You can picture that radius going all the way around, and you draw triangles lots of different places. So we're going to have x, y, and r. Now that I have these sides labeled, I can find any of my trig functions because I'll just label opposite, hypotenuse, adjacent, all of that stuff. Okay? So pick one. We're going to do one that's in this group right here and show where it came from. We're not going to go through all of them. Pick sine, cosine, which one do you want to do? Cosine, okay. Cosine I heard first. Cosine is the what over what? Adjacent over hypotenuse. So if you look at my picture, adjacent to our reference angle is x, right? And the hypotenuse is r. So adjacent over hypotenuse for cosine, we have x over r. Whatever this x point is over whatever this radius is going to give us our cosine. So all of these that they got right here that look kind of crazy and complicated, all they did is by doing opposite, hypotenuse, all of that stuff when they labeled their picture. Okay? So we're going to be labeling our pictures, then we're going to be finding all of these, which we've done before, but we've done it before only when these things are positive. Technically, in this picture, x and y are both negative if we're in quadrant 3, right? This is back a certain number. This is like -3 and -5. So this side would actually be a side of -3. This side would actually be a side of -5. So when we're writing sine, cosine, tangent in a second, we're going to have to pay close attention to the positive or negative, whether our answer is positive or whether it's negative. Okay, so let's take a look right here at what happens with whether we end up with a positive, negative, depending on what quadrant we're in. So take a look. We're going to skip these steps. I really want it to be... There we go. Oh. I do. Oh.
Is this you?
I just need it to be bent like this. I think I have a clip. Wait, Martin, go over there. Grab a clip out of the top of that thing by my stapler. The gray thing on top. Gray thing on top. Top. Go.
Gray!
Oh my gosh! Martin!
What's that kid?
Marshall! Up there. On top, by all the sticks. Go to the sticks. Okay, no, the clip, not the stapler.
Give him my neck.
Not yet.
His birthday.
Ta-da! Good job, Mark. Yay! Okay, we're back.
Public agent.
Clip solves the problem. All right, 10 minutes. Here we go. Eyes up here. In general, in quadrant 1, write down, do you all agree that if I give you a point in quadrant 1, it's positive x and a positive y, right? Positive x and a positive y. Whatever. Okay. In quadrant 2, we have a negative x and a positive y, right? In quadrant 3, negative and a negative. And in quadrant 4, points are positive x, negative y. Agreed?
Yes.
Okay. If that's true, then that means if I have an angle here, and I draw a little right triangle with it, that means my opposite, which is my y, is positive, and my adjacent is positive. My radius is always going to be positive, but if all these things are positive, then that means sine, cosine, and tangent are all going to be positive. Okay? In other quadrants, like for example, let's jump all the way to quadrant 3. If this is my angle, and this is my theta, and my triangle looks like this, now both of these are negative, and our radius is always going to be positive. So that means that sine and cosine, when you do y over r and x over r, are both going to be negative, but tangent is going to be positive because you do opposite over adjacent. What's a negative over a negative? Positive. Okay, so we can figure out the signs in all of the quadrants. And you can either memorize this or you can start to remember that sine is going to depend on your y, because it's y over r, like we just saw in the previous box. Cosine, we said was what over what? Look above. What did we say cosine was? In the box above. Cosine was? So it's going to depend on the sign of x, because r is positive. If cosine is negative, then, if x is negative, then cosine is going to be negative. Okay? So we're going to try to remember those as we go to figure out what quadrant we're in. So let's take a look at an example of a problem right here. It says let tangent be 5 over 12, where sine is less than 0, and find cosine. Whenever you're finding trig functions, you can draw a triangle, label what you know, find out the other trig functions. We did that before the break. However, we have to be careful about the positive or negative, so we need to know what quadrant we're in. So they gave us enough information to figure that out. So I'm going to kind of model how you would think about this. Johnny, you still with us over there? All right, so if tangent is 5/12, there's no negative in front of it, so that means tangent, we know right now, is positive. Agreed? Sine is the other one they give us some information about. It says sine is less than 0. If it's less than 0, Brian, is it positive or negative? Negative. Okay, so we're looking for a quadrant where sine, or like we said y, because we said that's related to sine, where sine is negative or y is negative, but tangent is still positive. Giselle, do you see a quadrant that works in? Which one? The third one. Y'all agree? If you look at your chart, that's the third one. So we're going to draw an angle in the third quadrant. There's an angle in the third quadrant. We're in the third quadrant, which means our reference angle is right here. And so we're going to draw a right triangle that looks upside down like this, not a regular one. That'll help us to identify the sign, as in the positive, negative of our answer. Mm-hmm.
Why would it not be a quadrant?
Sine is negative. So sine is only negative where y is negative, which is the bottom two, right? So we have to be in the bottom two if sine is negative. Because if you look at your chart, notice sine is positive on both the top ones. So sine is negative, but then tangent has to be positive.
Oh, okay, I see it.
Only in the third one. Cool? Okay. So now let's label. Tangent is 5/12. Tangent is which two sides? Opposite and adjacent. So we got O over A. So your opposite is 5. Go to theta and go opposite. This is 5. Adjacent is next to it. This is 12. However, now we need to place our signs, as in positive or negative. If this is 12, this is actually a negative 12, and this is 5 down. This is actually a negative 5. So notice they were actually both negative, but we would not write this as negative 5 over negative 12 because we would cancel the negatives. And so those negatives were like hiding there. If I would have just set up an old positive triangle, I would have missed that those are negative. Okay? Okay, whenever you've got a triangle, how do we find, if we've got two of the sides, how do we find the third side? Pythagorean theorem. Or, if you recognize this one, it's actually a Pythagorean triple. 5, 12, 13. You can do Pythagorean theorem, but you'll notice, I'm going to fast forward, C is equal to 13. And we said the hypotenuse is always going to be positive, so that one's a positive 13. All right, we've got our picture. We've got the positives and negatives placed. So now the last thing you have to do is just find the one they're asking for. We want cosine. Felix, cosine's what over what? Adjacent over hypotenuse. So taking a look. Kevin, which one of these sides, negative 12, negative 5, 13, which one is the adjacent? He says we want adjacent over hypotenuse. Take a look at the picture. If this is theta, which one's adjacent?
Negative 12.
negative 12. So we want negative 12 on top. That's our adjacent. Then we want hypotenuse on the bottom. Eli, which one's our hypotenuse? Which one's the hypotenuse? Negative 12, negative 5, or 13? 13! And we've got our adjacent over our hypotenuse from our picture. Okay? Figure out what quadrant you're in, draw your picture, label what you don't know, find the new trig function. Okay? Alright, flip the page. I want you to commit to at least one of these 4 problems. You could probably get to 2, but I want you to commit to at least one of them to practice before we get out of here, okay? So go ahead, try one out with your neighbors. I'm going to be walking around to help, okay? Go.
So neighbor.
I'll hang this up actually so you can see it. Okay. First thing you need to find is the quadrant, which in the last one we had to figure out. In this one, they just tell you which quadrant we're in. Which quadrant does it say? LL, which stands for So if you solve for C right here, you would have to like square this and square this. You'll get 25 plus 144. I think it's like 169. But I just knew there's these things called Pythagorean symbols, so there's a couple right triangles that some people just know, like if you have 3 and 4 on the side, just circle them.
Fun exam.
Do you ever see those? Yep. So if it's an angle here, then we're using the reference angle, which is from leading across. Where is that? Yep. So it's that theta in here, right? This angle. And so your right triangle has to be connected to the x-axis right here, not this way.
We're going to
Yep. It looks like a though if you draw all of them. Or we're in quadrant. Those. That's one. It goes like this.
I don't know. So we use coast.
Lovely. Okay, so we're talking about our reference angle.
So be x over r, right?
So now you want 5 over 7 is your sine. So 5 over 5 is your
Since you know it's 5 over 7,
yeah.
the opposite side is
Thank you. I hate when I do that because then I have to rewrite the whole thing. Okay, that's because Auntie is this side. I already redid it once, but I did that in the wrong color. But I'll use the wrong color.
25, what is that?
What happens when you watch a movie when you make yourself serious? That's when you do your homework and watch a movie. Okay, I'm going to draw the next one just so you can check it on your way out. But I would encourage, since we didn't practice all of these, if you feel like these are difficult, then maybe practice a few more. Really quick, eyes here. 5, and that's it. 7. If you solve this, you'll get root 24, but it's negative. And then this is your adjacent over hypotenuse, okay? We'll practice more of those, but... Yep.
Where were you going to reading?
If you typically don't see it as a decimal, we'll leave it as a description. Everybody, yes, I'm not worried. Come on.
No, always follow your dreams, right, Kevin? You know, it has some motivation for our viewers, right? Wait, what if my mother weighs something? Wait, let's tell me.
Thank you.